All right, so this is Unit 2, Lesson 7. We're starting with a math talk. So remember how those go. I don't want you to shout out the answer when you get the answer. Just put up your thumb, and I'm going to give an ample amount of time to let multiple people come to an answer. With the math talks, I discourage you from doing scratch work and or using a calculator. Supposed to be mentally dependent, help you build some foundational skills. All right, so, and also kind of just jot down the answer as we go through them. That's why it's still printed on your note sheet, even though I kind of don't want you to do it with scratch work. Whatever I write, you write. So, first thing, the question for all of these will be, is 0 a solution to each equation? So here's your first one. Then you have an answer, put your thumb on. Is 0 a solution to each equation? Riley, is it? No. And why?
Because this distribution process, you have to multiply
Well, that's right. We hang on with the other side. No, because the distributive property you said,
yeah,
and anything more to that, right?
just one word.
All right, who can add to Riley's explanation? Gavin? Correct, so,
So if you multiply 4 times 0, you get 0 plus 2 plus 2 plus 1.
did you say 4 plus 0? Okay, so even though you're right, like, it's not a solution, it shouldn't be 4 times 0, because order of operations should you do first. Well, what's the very first letter? Parentheses. So you do 0 plus 2, which is, and then the 2 times 4, which is, so we get this, which is 8 equal to 10. No. All right. Good. Any other strategy someone did out there? All right, it looks like with Riley, hers was more set up to kind of solve for X. So let's kind of do that real quick. If I'm trying to isolate X, what do I get rid of first? That 4 or the 2? The 2. So think of normally, like when we plug stuff in, like we have normal problems, we do order of operation normal, right? Parentheses, exponent, multiplication, division in the same step, addition, subtraction in the same step. But when we're solving, we actually kind of go backwards. We get rid of any addition, subtraction first. So like what's opposite of adding to? Whatever you do on one side. And then this is what I have so far. Right now it's being multiplied by 4. Opposite of that is good. So what does X actually do? 2. Which is not the same as 0. So another reason why. Good. Now this one again, don't call it out. Just put a thumb up when you have an answer. Is it a solution? Thumb up when you have an answer. Try to maybe see if the strategies your classmates used on the first one work for the second one. And then again, whatever I write, you should be typing. Daniel.
Yeah.
Yes, zero is a solution, why?
Because when you do it in like the Pandas form, it would be like 0 plus 4, which is 4, and then 3 times 4 is 12. And then you do multiplication next, so then you do 8 times 0, which is 0. And then 12 minus 0 is 12, so that's 12 equals 12.
Good, so in other words, you substituted, that's what it's called when you plug in to see if it's an answer, or that's how you can check your work when you solve equations, plug it back in, that's called the substitution property. So equation, both sides would need to be what? Equal. So if you solve each side separately, and yes, according to order of operations, so like on this side, would we do 12 minus 8 first, or the negative 8 times 0 first? So then it becomes 12 minus 0, which is 12. On the other side, what would we do first? Would we multiply by 3? Would we,
0 plus 4.
you would do the parentheses first, inside the parentheses, with 0 plus 4. What's 3 times 4? 12. So that is true, so good. It is a solution, 0. Any other strategy someone did out there? You also could have chose to solve for x. I probably won't show you that entire process, but like distribute first if necessary. Move the variable to one side and then isolate the variable. So that could have been another thing you did. And if x equals 0, then yeah, that's correct. Now this one, sum up when you have an answer. Is 0 a solution to this equation? If the sum up, then you just right, I'm seeing the same people try the rest of the class using the strategies they've already used and see if it works. So please, well, no problem. Lauren is the third one. Is the 0 a solution for the third one? Okay, Gavin, is 0 a solution for the third one?
Yes.
And why?
If you replace 5 or x with 0, 5 times, so they're multiplying each other, so 5 times 0 equals 0, and 1/2 times 0.
Good. So maybe the fraction threw some of you off, that anything times 0 is 0. So that one is true, 0 does equal 0, so yeah, 0 is a solution to that equation. All right, last one of the set, is 0 a solution to this equation? Unless when you have an answer. All right, Riley, is it a solution?
No,
And why?
because if you replace the x with 0, 6 divided by 0, 6 plus 1 is fraction, which is not.
What is 6 divided by 0? Is it 6?
If you type that in the calculator, it'll say error, so
Yeah.
yes, but and no.
So did you use a calculator on this
No.
one, or you just remember from like
No.
the past?
So we
Okay,
try to divide anything by 0, we can-
so that is correct. If you put that in your calculator, it'll say either undefined or it'll say error. So it is not possible to actually divide by 0. So what we end up getting is basically on one side undefined equal to 8. All right, regardless, the left side is basically unsolvable. So no, there's 0 cannot be a solution to that. Because it makes the left side undefined while the other side is still 8. So not equal. Questions on the warm up? All right, the intention here was to kind of review some properties. So like we have the distributed property when we multiply a number outside the parentheses inside. These over here, whenever you do something on each side of the equal sign, those are called properties of equality because you're making it equal. So because I had to subtract on each side to undo the addition and get the variable by itself, that would be the subtraction property of equality. Over here, what do you think this property of equality is called? What did I have to do on each side right here? I had to divide on each side. So that would be an example of the division property of equality. All right, you might see that pop up on the test one day, so. Take the time to tell you. And then of course, I don't know what this property is called. I don't know if it is property, but you cannot divide by 2. Just a few important like foundational things before we move on. So good. I'm gonna scroll down now to our first activity. So with pairs or with people around you, like be honest, if you want to leave and work with someone, that's fine. But in your pairs or in your trio, if you're a group of 3, you are going to basically explain. What this is saying is that we're going to choose a pair of equations from column A. So if I'm the first partner, maybe I take the first one. And choose a pair of equations from column A and explain why if X is a number that makes the first equation true, it also makes the second equation true. So we're telling you that X would be the same in both cases. You can explain why. Then for the pair of equations from column B, you're going to explain why the second equation is no longer true. So explain why X is true for both in column A, and then in column B, explain why X is not true for both. So we're going to do that, and since there's like basically 10 pairs, I'm going to give you about 8 minutes. Is that fair? Okay, we'll do that. So I'm going to put you on timer for 8 minutes, explain within your groups. We'll go over it like the last 2 minutes. So 8 minutes and then 2 minutes. Some time. Let's kind of go over some that I think by the time we get through them, it covers all of what we need to know. So in A1, we already said that the A column has the X's as the same for both equations or different. The same. You just have to be able to explain why. Well, let me share. So why is it the same for A1? Yes. Because 9 times 4 is 36. Anything else? Good. So once we distribute in the first one, we get the same exact equation. We get 36 minus 4x. Because it's the exact same, I know that when I solve for x, it will be. All right, questions on A1. Now, why isn't, because remember the B column we said would not be the same for both equations, yes? So why in B1 is it not the same? So give me more. How did you figure that out? Did you do any steps, Lauren?
Oh, wait.
But isn't 9 plus 5 14? But over here, 9 plus 5 is not 14, wouldn't it be the same? Why not? It's on the other side of the equal sign, so I can't just add 5x to each side. Yes, so that's what I was trying to get you guys to say. If I were solving for x or trying to just move the variable to one side to make it look more like the bottom one, you have to, well, let's just say if I were to add 5x to each side, does it go away on the right side? No, it becomes 10x on the right side. The left side would now be 14x, and now the right side would be 10x plus 4, which is not the same. But if I were to subtract 5x from each side, that does cancel this out. I get 4x equals 4, which again is not the same as 14x equals 4. We can stop right there. They look more similar now, that I can really compare them, and I know that it will not be the same. All right. Any others that you thought were tricky or that you maybe didn't want to, let me, just give them a copy of this. Let me do very good at that. Which request would you like to see? Any? 3, this set, like this old one? Yeah. Okay, so in 3, why is the first pair a solution? First pair of equations, why do they have the same answer? Anyone? Do you have an answer? All right, so let's see. If I were solving the first one for x, what would be my first step? And this one right here that I'm looking at. What do you always do first if you can? Well, in the parentheses, I can't simplify it more. But when I have parentheses in this format, what do I do? What property? Distribute. So first step in solving equations is always distribute if necessary. So that's what I would do first with negative 3 times 2x. What's negative 3 times 9? I got you. I got you. Now, for the x, in isolating it, what would we get rid of first? So you want the x by itself, you want to move the x, what would you move? And how can I make that negative 27 0? Whatever you do on one side. You guys know what that property is called? By chance? The addition property of the solve. So I had to add on each side of it. On the right, what's 12 plus 27?
39.
All right, so this is what I have here. Now keep going, let's just keep going. Opposite of multiplying by negative 6 is whatever you do on one side. What would that property be called? Division property of equality. Good. What's 39 divided by negative 6? Is that a decimal? Can someone approximate that decimal for me? So negative 6.5 is what x is. Now I could solve for x, but now that we're trying to see if it's true or not, I'm just gonna plug it into the second one. All right, so I have 2 times -6.5 plus 9, if that equals -4, then it is true for both. So what's 2 times -6.5? So I'm gonna put that happens, just as you out, I will steps and you're gonna do that. -13 sounds right. What's -13 plus 9? You'll use the calculator now. -4 is correct. So yes, it is a solution for both. They have the same X. Questions on that set? Brayden, where'd you put your test? Okay, don't put things on my notes. Just leave them on the back table. All right, so now the one next to it. We know that X should not be equivalent in this set. But we need to explain why. So what was your explanation for why? As what you guys were saying earlier is like, they're just not the same. They're not the same numbers. Well, these were not the same numbers. I couldn't make them look equivalent to each other, but X is still the same solution for both. So why is X does not have the same answer for both of these equations? Did anyone solve for X? Well, then let's try solving for X. Maybe we just forgot how to. If I am solving for X, anytime really, I go through the same steps. I distribute if necessary. Do I need to distribute in this one? No, because there's no parentheses, but you go through the same steps. You go check for everything first. Distribute if necessary, combine like terms if you need to on each side of the equal sign. No like terms, right? Then third, move the variable to one side. So because that's like that, we move the variable to one side. Doesn't matter what side I move it to. It does not matter what side I move it to. There's some that might be easier, but it really doesn't matter. So I heard, let's move the 6x. How can I make the 6x 0? And whatever you do on one side, on the left, it cancels out. On the right, what's 3x minus 6x? Good. So I don't know if you caught on, but when you're combining like terms, like with variables, you just basically combine the coefficients and you just leave the variables. 3 minus 6 is -6. Now get the x by itself. What's opposite of multiplying -3? Good, whatever you do on one side. And then x equals a +2. Now that's what it equals for the first one. If I plug it in for the second one, and remember there's 2 spots you would have to plug it into. What's 2 minus 1? Right, I plugged it in right. What is 2 minus 1? And then 3 times 2? 1 does not equal 6, right? So 2 is not a solution for that bottom one. So then that's how I can explain why. Because when I solved for the first one, I got x equals 2. And I plug in 2 for the second one, it doesn't work. Question? Yes? Oh, 4. Okay. And A or B?
Yes.
Both? All right, so actually we really like this example. So this is something that students like fudge up all the time. So here's when I say 3 minus x is the same as negative x plus 3, aren't they?
I mean,
Isn't the x still negative in both? Yes, isn't the 3 still
Oh, yeah.
positive in both?
oh yeah.
Yes, so let's say x was replaced with a number, right? Let's say it's replaced with 1. Don't I get the same answer with 3 minus 1? What's negative 1 plus 3? And they're both still positive. So the left side of this equation is equal, and so is the right side. So without even solving for x, I can tell you they're equivalent. You need to do this one too?
What would you write down?
I don't know how to summarize that. 3 is positive in both, x is negative in both, they're both on the same side. The left side is completely the same, so they're exactly the same thing. I think there's actually a property you can use. I'm not super positive, but I think it's the commutative property. When you can write things like in a different order, and it's still the same. Like 90% sure that's the commutative property. Any other questions? All right, because I do want to move on. So, and I also want to give you time to practice. So let's look at the next activity. Let me zoom out. But yeah, this is, I love these like find a mistake problems. They're really common on tests. So Noah's having trouble solving 2 equations. In each case, he took steps that he thought were acceptable that ended up with statements that were clearly not true. Analyze his work on each equation and moves made for the acceptable moves. Why do you think he ended up with a false equation? Discuss your observations with your group and or your partner, or at least you better look at it yourself. Very minimum, better look at it yourself. And be prepared to share your conclusions. If you get stuck, consider solving each equation. So here's the problems. I believe everything is all printed on your paper for this. Try to see if you can find a mistake. And maybe see how you can fix the mistake. For the first one, are his moves acceptable? Yes or no? Did he make a mistake?
Yeah.
What do you think the mistake is? I mean, isn't writing 1 minus 3x the same as writing negative 3x plus 1?
Oh, I mean, is it?
Isn't the 3x still negative in both situations? Isn't the 1 still positive in both situations? And additionally, so it's still correct because of the commutative property, that is correct. But you would also have to combine like terms first anyway, before you do anything else. And that's what they did. The 4x minus 3x, they just moved it, I guess, to make it easier. I don't know. So that is acceptable. Any other, did you make a mistake ever?
Yes, the third line.
What's the mistake here?
Well, because after the third line, it just seems like he just made the X disappear.
So that's a good point that you bring up, because on the test, when they're showing you the steps of the problem, they're not usually showing you the scratch work to get from line to line. So like, what did they do to make the X's disappear?
They subtracted one of the X's, and then
Yeah, because ordinarily after you combine your like terms, you would move the variable to one side. Well, if I want to move this X, I would have to subtract it, whatever I do on one side, to the other. But then it completely cancels out. And I'm left with no variables. I have 6 equals 1. Is that true?
Yeah.
No, it's not true equation, that's not.
No way.
It
Yeah.
is not true. So do you know what the answer is when the variables cancel out and you get something that's not true? Good. That is one of our learning targets, to recognize when there is no solution. And that is when you get a false statement and the variable cancels out. But what about over here? Did you make any mistakes? No, make any mistakes? What was the mistake? So I feel like here's where it starts to look a little weird. Ordinarily, I would move the variable first to one side. I don't know that that necessarily makes it wrong, but I would normally move the variable to one side first. How would I move the variable? Subtract 2x on each side. Then I would have ended up with something like this, with 3x minus 2x. 1x, a positive 1x, is minus 1, still there. And then I would keep solving, and I can actually get an answer for x. How would I get the x by itself?
Oh, wait.
Add 1, because that's how you get the x by itself. That's how you make this 0, is by adding 1. And then you get x equal to what? 0. So for some reason, I don't know what they did exactly here. They added 1 to each side and then divided each side by x. Should I divide variables on each side ever? No. No. So that is where a mistake was made. You could add 1 to each side and that's fine, I guess. So once you subtract the 2x on each side here, you still end up with 0. That's not necessarily wrong, I just wouldn't do it. This is where I'm mistake. Questions on anything we learned today? All right, I never showed you the slide, so I never showed you what the goal was, but let's see if we met the goal. If you can explain why some algebraic groups create equivalent equations but some do not, then you met the goal, like what we did in the second activity. If you know how equivalent equations are related to the steps of solving equations, so like when equations are equal, they're the same on both sides, then you met the goal. And if you know what it means for an equation to have no solution and can recognize that, then you've met the goal. All right, you have a puzzle piece. Also listen, so this is important. Are you listening? Hold on. Chill out for a second, stop moving. I want you guys to start working together on the puzzle pieces while you're in class. So like with your partner or with your trio, I unrandomized it. Listen, stop talking. I unrandomized the problems so that you have the same number 1. I don't want you to keep moving on until you guys agree on an answer. And if you can't agree, then that's when you would ask me a question. All right, that way we can get more done together. Stop talking. I'm still talking, so be rude. All right, additionally, if your partner is kind of useless, they're not helping, they're not contributing to the conversation at all, then don't give them the answer. All right, they need to contribute if they want the answer. I understand that some kids maybe are like the stronger ones in the group and carry the weight, but if the other person's like just wanting to mooch off your answers, then don't give it to them. All right, the whole point is to invite them into the conversation and work together. So that's what I want you to do from here on out. Our next test won't be until Wednesday next week over lessons 6 through 11.